Hello everyone. So in this video we are going to learn about some basic formulas of differentiation. We are starting this series which we will continue with some short tricks about differentiation. Okay. So here we are starting very first video in which we are starting with very common differentiation things. So here what is differentiation? First of all we should understand the meaning. Differentiation basically is, suppose you have a function y is equal to fx and dy by dx is differentiation. If you are calculating rate of change of anything with respect to anything, like how distance is changing with respect to time, then y will be distance function and x will be time function. So it is like rate of change of anything. Okay. And what do we follow in differentiation? We are differentiating, mean we are separating, means we are reducing. How? Like what is the first formula here? This is the most common and most important with which we derive both of these formulas as well. So what is differentiation? Like we had power n and what we get? Power n minus 1. So we reduced the power by 1. And when we took n here and we reduced the power by 1. So it is reducing. We are reducing the power. We are differentiating. Okay. One point is integration, where we combine the things, we make the unity, and this is differentiation where we are reducing the things. Okay. So this is d by dx of x raised to power n can be anything. So here what did I do? N can be positive and negative and in fraction as well. So what did I do here? I wrote n as this. If we have minus n, what can we do then? And if we have 1 by n, then what can we do? So I just modified this formula only. So we are doing this example here and we will see how do we apply these formulas. So this is d by dx of this. First of all, I will tell you one formula. If you have d by dx of two function or three function which are in addition or subtraction in anything, okay, then what do we do? We just separate it. Okay. If we have plus, then we write du by dx plus dv by dx. If we have minus, we will write du by dx minus dv by dx. Okay. So here we have this, so we will separate it. D by dx of x cube minus d by dx of 3 x raised to power minus 2 plus d by dx of 4 under root x plus d by dx of 6. Okay. So differentiation of any constant is always 0. So differentiation of this will be 0. So first of all we start with this. D by dx of x raised to power 3 is n x raised to power n minus 1, that is 2. Okay. Minus 3. We write 3 as it is. Okay. And we will differentiate this part. If we have any constant with variable, we write constant as it is and then variable. Okay. So what will be the differentiation of this part? X raised to power minus 2. Minus 2 and x raised to power, we just subtract the power. So it will be minus 2 minus 1, that is minus 3 plus 4 under root x, means x raised to power 1 by 2. 1 by 2 will come here, x raised to power 1 by 2 minus 1. Okay, and differentiation of this part is 0. So we get 3x square. 3 into 2 is 6, minus minus is plus, we get 6, and this is, we can write it here, 6 upon x cube plus, we can cancel it, this is 2, this is x raised to power 1 by 2 minus 1 is minus 1 by 2. So we write it here under root x, and whenever we get under root x in denominator, we just get it with this. So you will get 3x square plus 6 by x cube plus 2 under root x by x, which is the answer. So I hope you understood. So instead of I just did minus 2 and then I subtract 1 power, I applied this formula only. Okay. So what if you just apply directly this formula x raised to power minus 2? Then you can write this is minus 2 upon x raised to power 2 by 3 because n is 2 here. So 2 plus 1 is 3. So we will get here directly minus 2 by x cube. Okay. If you apply directly these formulas. So you can learn these formulas as well or you can apply this formula only. So this was very basic differentiation. So after this we will start with another formula. We discussed four formulas of differentiation. Now we have these four formulas. Like if we have a function log x, then differentiation of that function is 1 by x. And if we have e raised to power x, then differentiation of this is e raised to power x only. Now, what if we have product of two functions, u, v? Then you write first function and differentiate second function plus second function and differentiate first function. So we need to differentiate both the function. But what do? We write first as it is and differentiate other and then write another as it is and differentiate first one. And what if we have u by v? Then this is v du by dx means the denominator function here and then differentiation of this function numerator function minus numerator function differentiation of denominator function and then upon whole upon its v square means denominator function whole square. Okay, so now we have d by dx of x e raised to power x plus log x. So first of all that formula that if we have two functions and we have addition here, what do? We just separate like this, d by dx x e raised to power x plus d by dx log x. Okay, and after this now we got a product function here. This is u and this is v. So it is u and then differentiation of v plus v and then differentiation of u plus d by dx of log x we know is 1 by x. Okay, so x, what is differentiation of e raised to power x? It's e raised to power x only plus e raised to power x. What is differentiation of x? This is x raised to power 1. That means 1. X raised to power 1 minus 1 is 0 plus 1 by x. And basically differentiation of x is 1 only. Okay. How? X e raised to power x plus e raised to power x. X raised to power 0 is 1. So this only plus 1 by x. So this is the answer of this question. So I hope you understood this trick. This is very simple. Product of two functions. How do we differentiate? And this we will start in next video. Okay. So if you liked it, please subscribe to my channel and thank you for watching. Bye bye.